Wonderful. Thanks for that introduction, Tammy. I appreciate that. I'm going to share my screen. Hopefully the last screen share we got to do today, but we'll see. All right. If everything's working correctly, you all should be able to see the engineer's playbook starting a new role. Yeah, perfect. Let's go ahead and get into it. So as Tammy has mentioned, my name is Cameron Presley. I am a team leader at Rocket Mortgage. All that means is that I work with a bunch of engineers to go build cool stuff. As Tammy's also mentioned, over my career, I've led various teams. So I've got a little bit of experience on how do we onboard engineers? How do we make them effective? How do we make sure to really set you up for success? So in today's presentation, I'm going to walk you through how I like to onboard engineers, some tips and tricks that I found to be helpful in my career, and advice I've given to new engineers. By the end of this presentation, you will actually have a playbook, essentially a game plan on what to do if you're starting a new role, or if you happen to be in a leadership role, some guidelines and goals that you should be doing to help set up your engineers when they start. So let's go ahead and begin, right? Day 0, congratulations. You have accepted a job offer. Welcome to the world of software engineering. Things are exciting, right? You fill out the paperwork, you've met all these cool people, you've started telling your friends and family, you're starting to celebrate because you finally done it, right? So maybe it's because you've gotten through your boot camp program and you now have the skills. Maybe it's a college graduation that's done it, or it's just your own internal training, but you have figured it out, you've got it. So you show up on the first day and you're talking to a few people and you kind of get the impression that this place operates a whole lot like this. Whole bunch of words, none of it making a ton of sense, but everyone's kind of carrying around that it's normal. And you're like, I don't know. So then what happens is that you sit down, start trying to learn all this stuff, right? All the new words and people and phrases and such. And it feels like you're drinking from the fire hose. Right? It's too much information all at once. And it's really just mind melting, to be honest, right? It's just too much. We can't keep track of it. So then you go back and you've got this labyrinth of confusion trying to navigate your way through. So what do we do? Well, let's talk about our first steps, right? And to me, our first step of really trying to unravel this puzzle is, what do we mean by success, right? What constitutes success? So in my world, success for a new engineer joining and what you should be aiming for is, are you fitting in with your team, right? Typically when you join a company, you're going to be working with a bunch of peers. Are you able to get along with them, have good conversations, fitting in, picking up those social norms, right? Another success criteria are things like, do you feel like you can do your best work? Right? Some places will call this psychological safety, but if you can be yourself and really give forth your best effort, you're really going to be successful. But do you feel like you can do that here? And honestly, right, as a team lead, something I'm looking for to make sure that you're successful is, can you take on work solo, right? If I give you a task to pick up, can you kind of go run with that? One thing I find, though, is that engineers get hung up on working solo. You mean working alone? Not quite. When I say working solo, we're really talking about owning, right? Owning the work independently. And to do that, that means you're going to have some tools, some skills, and some knowledge to figure things out and how to work with others to accomplish these tasks, right? So we've got a little bit of success criteria. Do you have the tools, skills, knowledge? Are you fitting in with people? Do you essentially know what's going on here? But how do we get there? And what I found is that there's really 4 pillars, 4 main concepts that if you start getting some comfort with them, some knowledge, your onboarding is going to be a lot more successful, right? So that first pillar is understanding the problem. What are we trying to solve, right? At the end of the day, you got hired on to write code to try to solve some type of problem. You probably want to understand the problem you're trying to solve, right? If you don't understand the problem, you're going to have a really bad time, right? What's the technology stack, right? So what tools are we using to solve this problem? Are we just writing web applications, mobile apps? What are we doing? And okay, even if it is a web app, what's all the stuff we need to work with that? Because if you understand the problem, but you don't understand the tools, then you can't really use the tools effectively to solve the problem, right? So as you can kind of see, there's a theme building up here. All right, let's talk about processes, right? How do we work together to solve the problem? Just because you have the tools and know what to solve, How do we work together? How do things get delegated? How do I know how to collaborate with others? Oh, and speaking of others, how could we possibly forget people? For the most part, you're probably going to be working with a team, right? So you're not working by yourself. So who are you working with? What are the types of people you're working with? How do they fit into this bigger puzzle, right? You've kind of got this menagerie of things going on. It's like four-dimensional chess right now. How in the heck are you supposed to navigate all of this? Well, that's what I'm here for. I'm going to help you out a little bit. I'll go ahead and help you out, though, a little bit right immediately. You can't be an expert in all this stuff on day one. Do not do it. Do not go past go. Do not collect $200. It's not going to go well. It's too much all at once. So my goal is to help get a base foundation of knowledge, right? What's that thinnest amount of info that you need to know to start being successful? And then over time, you're going to learn more about all these other things. You're going to learn a little bit more about the problem, a little bit more about the tech stack, a little bit more about how things work around here, a little bit more about the people you're working with. Right, but you got to have that kernel first, and that's what we're really going to be talking about. And the reason why it's so important to kind of build this base foundation of knowledge is what I found is when I start a new role, and most engineers do, they sometimes aren't confident, right? They are in an unknown environment, talking to unknown people, doing unknown things, right? Very few people would walk into that situation going, oh boy, I'm excited and ready to go do this. Right. But if you can build up a little of this knowledge, you get a little more confident. As you become a little more confident, you start becoming more comfortable. And it's when you start really becoming comfortable that you can really start excelling. So let's talk about how we can get you there. So step one, there's some prerequisites we got to do, right? So before you start any role, here's some things you need to do. Let's talk about notes, shall we? So when you're starting a new role, there's a whole bunch of stuff happening, right? You're learning a lot of things, so on and so forth. And this is somewhat problematic because as a human, your mind is awesome at so many things. It's really great at problem solving, for example. It's naturally inclined to do that. And in fact, if you're an engineer, you're more likely inclined to be problem solving focused anyway, right? But one thing your mind kind of sucks at is information retention. It's not good remembering things. Right? It also isn't great remembering things when you're under a lot of pressure or stress. So if you're at a new job, learning things on the job, you're probably a little bit stressed, which means that can hurt your knowledge retention, which then makes you more stressed. And the next thing you know, you're not having a great time. So one thing I'd really advise doing is you're going to need to take some notes. And the reason why is because A, it helps you retain that information. Studies have found that if you take notes of some sort, whether handwritten or electronic, it helps you learn a little bit more. And it also gives you a way to find this stuff later, right? You're not perfect. You're going to forget things. If you don't think you are, try remembering what you did around this time last year, right? I guarantee those memories aren't as sharp as you would hope. So how do I take notes? So I use an electronic system called Obsidian, and it's a free tool. You can install it on your machine, works for both Windows, Mac, what have you, allows you to add files in a format called Markdown, really easy to search. It's my preference. Talking to a few other engineers, they found success using tools like Evernote or OneNote. Another product I've heard some good things about is NoteJoy. I've not used some of these products extensively, but if you're looking for an electronic version, any one of these can help you out. And for the most part, they are either free or very reasonably priced. The other pro tip I will give you is, depending on the company you work at, they may also have a recommended note-taking tool of choice. So you might even be able to use that. But from my perspective, I actually don't care which tool you use. I don't even care if it's I don't care if it's electronic or paper. I don't even care how good your notes are, honestly. Like, I don't care if it's the bullet note-taking system or what have you. The important thing is, can you find what you're looking for later, right? Because here's what's going to happen. You're going to talk to an engineer, and they're going to tell you about the foobar process, and they're going to tell you that the foobar process is super important. And you're going to listen, and you go, mm-hmm. And then 2 weeks later, you're not even going to remember what the process was called. And that's a bad thing. Right? That's why you need notes. That's why you need to be able to keep track of this stuff. Making sense so far? Right? Kind of, right? Taking notes. You're like, dang it, Cameron, this is back in high school. We've been there, done this. Well, let's keep going down this path. Another thing you're going to want to do is know how to keep track of stuff. So if you've got a note-taking system, you're going to need some type of task tracking system. And the reason why is you're going to have a whole bunch of stuff in flight. Some of it's going to be development work, right? Fix bug, get code reviews, that type of stuff. You're also going to have a lot of non-development work, onboarding processes that your company may have, mandatory trainings, all the paperwork to fill out, right? Once again, you don't want to rely on just your memory to keep track of all this stuff, especially when you're going to get bombarded with chat notifications and emails and all this other stuff, right? So you're going to want to have a system to help you out with this. And so the system, so whatever system you use, once again, I don't care, I'll give you my recommendation though, is you need to know what tasks that need to be done, how important they are, and also, are they actually done or not? Right? So if you have a system that can handle all of those things, you're doing great. So the system I like to use is called Getting Things Done. So this book has been around for quite a while now by David Allen, and I really enjoy this process because it's not tool specific, it's process specific. And the general gist of this is as things come in, you capture that, put it in your system, and then once you've got everything cataloged, then you can prioritize things. And so it's a great way of giving a visual to the work that needs to be done. And I already mentioned that doesn't use any one specific tool. My recommendation is go borrow this book from your library. Most likely they'll have it in stock. And if not, though, you can always find a couple of resources online for free. They'll talk a little bit about how to implement such a system. Personally, I use a tool called Trello, and that's how I implement my system of getting things done. However, there are tons of other systems out there that you can use as well. Pivotal Tracker is one I've used in the past. It does pretty solidly. Asana, Kanban Flow. I was talking to someone earlier, and they mentioned Microsoft Planner. So if you're at a company that's very heavily in the Microsoft like Office suite, you might be able to get away with those things. So, and I'll actually show you at the end of this presentation what an example Trello board would look like. I also like Trello because it's free for the most part, and it's just a really solid tool. The third thing you're going to need, though, to be successful is curiosity, right? So for those who are kind of known to the joke or the meme of from the sales side of things, always be closing your ABCs. I actually propose a different ABC that we should be doing. Always be curious, right? Be inquisitive, want to know how things work, right? You are wanting to be an engineer by design. That means you are fascinated on how things work, how they hang, how they interact, why we do certain things. You want to know this stuff, right? So a way you can kind of jumpstart this thinking, especially when you're starting a new role, is ask tons of questions. I encourage engineers that join my team to ask at least 3 questions a day. And if they're not asking at least 3 questions a day, I'm not challenging them enough. And if I'm not challenging them enough, that's a good problem to have, right? Cool, we can find harder stuff for you to get into, right? So at this point, I've given you kind of some of the tools of the trade that you need to be successful. So now let's start talking about our prerequisites, right? Let's start talking about these 4 pillars. First thing we got to talk about is understanding the problem. What in the world are we trying to do? Look, I ain't going to lie to y'all, right? You were hired in to help solve a problem. That is why you're drawing a paycheck. That is why you're now an employee or a team member at whatever company you're at, right? You got to know this problem. To make matters even worse, this problem is most likely complex, has a bunch of terminology that you may have never heard of before, and it has very complex rules. That is not the easiest thing in the world. There is a phrase that we use in our industry to capture all of this. So when you're talking about a problem and the solution and everything in it, we typically refer to it as the domain or the problem domain. And you're maybe thinking, all right, Cameron, well, this is a very generic thing. Maybe it's a math term. I don't know. But what do you mean by domain? Can we go a little bit more specifically? It's like, of course we can, right? So Tammy kind of did this a little bit in our introduction, but here are some possible domains. These are domains I've worked in, but these may be domains you get into. So right now at Rocket Mortgage, I'm in the wholesale mortgage industry. And our kind of big goal is we help our partners close their clients' loans quickly and efficiently so that our clients can get into homes sooner, right? We want them to be able to sell their home and get into their new home or refinance their home if need be, right? In a previous life, I worked at a company that did SQL Server database monitoring, right? And so it had a whole bunch of domain terms and terminology and very technical. But at the end of the day, our big thing was trying to help database admins discover their performance bottlenecks before their users did, so they didn't lose customers. And before that, I worked at a place that did government project management, where their big problem we were trying to solve is, hey, we've got all these projects and then things change, so we got to move projects around. Man, that doesn't sound familiar, right? Things changing, you got to shift all your projects around, right? And we need to know, like, if we move things around, what all changes to. So even though these are very brief statements, you can imagine that there's a lot of detail in each one. So let's take a look at one of these, right? Let's take a look at the SQL Server database monitoring one. A good problem description and a good problem statement will have the following three things called out. Who are we helping, right? At some point, someone's using this product, right? They're using the software. They have handed your company money to use it. So who are they? Why do they need it? And what are we doing to help? That's the second part, right? We're helping these people and we're helping them to do something. Otherwise, they wouldn't have bought the product. So what is it that we're trying to help? And most importantly, why do they care? Why do the people we're helping care that this thing exists? If you understand these three spots of your problem domain, you can become a very effective engineer, because then you can ask better questions about why are we building certain things? Why do customers care that we're doing this versus this? And you can actually become a lot more engaged. So let's take a look at that example I gave earlier and break it down. All right, so here's kind of our problem statement. Well, who are we helping? Oh, we're helping database administrators. That's cool. What are we doing to help? We're going to help them discover their performance issues in the database. And why do they care? Because when database admins have performance problems, that usually means their applications have performance issues, which means users see that. And people that use our products and it looks slow or times out, they're not happy. They'll take their business elsewhere, which makes the company not happy, right? So even in a very short description, and you all not being experts in this stuff, you have a rough idea of what the problem is and what we're trying to do to solve it. That's the first step, right? That's the first step of really understanding. And we can go a little bit deeper on why people need our software. Sometimes it's because trying to do the thing, whatever problem we're trying to solve, doing it manually, it could be painful. Maybe it's very time intensive. Maybe it's very error prone. Maybe it's just not even feasible to try to do it manually because there's just too much, right? Sometimes the reason why they need your software is because it's cheaper to delegate that software than having someone do it. For example, right, I run a side business. It's a lot cheaper for me to pay $10 a month for accounting software than it is to have an accountant on staff, right? So that may be a reason why somebody needs our software. And then last but not least, regulatory reasons. Yay, you're having to satisfy some governmental regulation, and software helps you do that in a really nice automated fashion, right? And there could be more than these reasons, but here's a couple that came to my mind when I was thinking about it. And why am I spending so much time talking about this stuff? Well, it's because when we learn who uses the software, what we do to help and why they care, we can really think about why they want to use the product. And once we start thinking about why they want to use the product, we can then be a lot more effective of what we should be learning and what we should be focusing our time and energies on. So instead of learning this thing over to the side just because it's here, we can learn about this other concept instead because our customers care about it, our users care about it. And when you start thinking about engineering in that way, you're going to be a lot better of an engineer. So some things, some tips and tricks I have for trying to learn the domain, right? Domains are very complex and they could take months or even years to fully understand. The company I mentioned earlier where I was doing database performance monitoring, I was there for almost 3 years and I still think I only know a third to maybe half of that domain. And that's putting it very, graciously, right? Like it's a very wide half of understanding it. But there is a core amount of knowledge to any problem that if you happen to know that, you can handle it. For those of you who are familiar with the Pareto principle or the 80-20 rule, essentially in this context, it means you can figure out about 80% of what you need to do. through about 20% of the problem knowledge. So to put this in other words, let's focus on the common workflows, not the edge cases, right? If you know in general how a thing works, that's good enough to get started. And don't worry, you'll learn about those edge cases as they come up because you're going to break something. And as an engineer, congratulations, breaking stuff is actually part of your job description. The trick is breaking it before your customers find out. Putting it another way, right? I see engineers all the time wanting to start off with like rocket science and calculus and physics and all that. And in reality, we just need to start with basic math. Let's get you comfortable with this first, and then we can level you up, right? So other things to help level up your domain knowledge, right? Remember your ABCs. Always be asking those questions. Be curious. And a trick I like to use is ask. So if you ask the question about why this thing works, ask that person how they knew that, right? So coming up with an example of, hey, James, why did you know that this particular piece of data was in the database here? And James goes, oh, yeah, it's because Microsoft has docs on SQL Server. You can find it here. I can then go, oh, there's docs I can look up. Ah, that's how you knew that. Okay. So now all of a sudden, I'm kind of doing a life hack type thing where if I know how they knew it, I can just bypass them all together. Instead of asking them questions about how do you do something, it's more of, hey, I found this and this seemed a bit weird to me. Can you talk me through why that makes sense? Now your questions are a lot more effective. They're a lot more efficient. And sometimes the way they know stuff is through blog posts or wikis or certain books, certain articles, or other industry resources. So sometimes it's just because you read through all the code, right? So make sure you're using the correct resource there and just ask those questions. Some other advice here. You're in a meeting and someone drops a term that you have no clue what it means, write it down for later and follow up with someone to ask about it because you're taking notes, right? That's why we're doing this. However, if you're in a smaller meeting, maybe it's just your team or maybe a couple people, feel free to ask the question, right? Feel free to be like, hey, sorry for interrupting, but I'm not sure if I know what blank means. Can you explain that to me? Pro tip, if you have the question, it's very likely there's another person in that group that has the same question, especially the larger the group gets. And most people are going to be super excited to tell you all about that thing, whatever that thing is. They will be more than happy to probably talk to you for a whole hour about it if you had so wanted. But to continue on, right, as you're learning about the domain, you're learning about the terminology, it is key critical that you use the same terminology with your team. You'll sometimes hear this known as a ubiquitous language. But the reason why this can be problematic if you don't is, let's say you're working on a product and there are different kinds of users that can use it. So I'm going to go to the mortgage industry. Maybe I have a loan officer versus a loan processor who's using the product. Well, if I'm talking to an engineer about, well, I'm trying to do this thing for the loan processor, but it's not working, but I really meant loan officer, I've now confused the other engineer and they may give me bad advice, right? They may tell me the wrong thing because we're not talking about apples and apples here. We're really talking closer to apples and oranges, and that's problematic. Your fun fact is I actually made that mistake, I think my third week on the job. And thankfully someone else caught me and was like, oh, no, Cameron, you meant this other thing, right? And I was like, no, I don't think so. And they're like, no, you did. Let's talk about why you messed up. Right? And that's normal and that's okay. But making sure you're consistent with the terminology is helpful. Are we domain experts yet? Yes, no, maybe? We'll keep it going then. So let's talk about the tech stack, right? So how are we solving this problem? And yes, this is technically a stack. Yes, there's a data structure called a stack. We're not really talking about either of these things per se. When we're talking about tech stack, we're really talking about all of the technologies that are used to create the software that we're building. And some of you may be like, yeah, it's just some JavaScript. It's just some C#, it's just some Java. Like, how much could it be? A bunch is the technical phrase, right? And the reason why we want to talk about tech stacks is because what we have found in the industry is that certain problems typically like to be solved in a certain way. So, for example, let's say that we needed a way for someone to enter some data and that data needs to be shared with others. Well, one way to solve that problem is a web application that has a database. That's a really well-known architecture. That's a really well-known solution that tons of engineers could go knock out, right? It's a known thing. But let's break this down. So we know if we're going to build out such a product, we know we're going to need something to display UI, right? It's got to display some stuff. So you'll typically either hear that as the UI or the front end. You're going to need something to handle the request that the user is saying, right? So if they want to enter in data, click submit, right? Handle some of that. You're going to need to have some type of API and backend component. And then I heard you're storing data. Congratulations, you got a database component, right? So you're already kind of breaking this down a little bit. Like, well, we've got a web app, and a web app has these three pieces. If that logically makes sense to you, congratulations, you understand what system architecture is, right? This idea of taking a system and breaking it down into its moving pieces. All right, I hear you all say, but Cameron, it's a front end, right? Yeah, there's a front end, there's a back end. How complicated could those be? Joke's on you. The answer to that question is yes, absolutely can be. So here is one way we can build out a web application. Maybe we have the front end as the Angular framework with TypeScript, and those two things are going to be talking to a C# .NET Core API backend, and the data is going to be stored in Postgres, right? That's one architecture we could go with here. Another way we could build out a same web app, so from a user perspective, it would look exactly the same, could be React and JavaScript for the front end, Node server and more JavaScript on the back end for the API calls, and storing all this data in MongoDB. Two functionally similar applications to your users and your customers, but from an engineering perspective, vastly different, completely different languages and tech stacks, right? So to make matters even better or worse, depending on who you are, the code needed to make all of this work can actually be quite complex, right? Especially if it's a larger application, there could just be tons of code, hundreds of thousands of lines, millions of lines of code. The good news is that companies have some pretty sharp ways of dealing with complexity, right? So typically what I found is that engineers on a team will either own a piece of the application or they'll own like a whole component of it. So maybe you are on the team that only does the front end changes, or maybe you're on the team that deals back end. You could also be the team that says, oh yeah, we handle anything in the application that is related to rate changes, right? So rate changes on a loan, right? So my advice here is you should focus on 100% what your team owns. So if you're owning the front end, you need to be really comfortable how that front end works. If you're owning maybe the business rules for how we calculate rates, you need to be really comfortable with that. And while you're learning all this stuff, you're going to, so if you're owning, like, let's say rate calculation, you should be learning how does that fit into the bigger picture of things, right? So if I've got a partner registering a loan, I care about that rate being calculated correctly. And it's like, okay, well, where does that happen? Does that happen at the beginning? Does that happen at the end? Where does that come in at, right? So you're going to care about that stuff. Excuse me. So, and the reason why it's important is because once you understand how your piece fits into the bigger picture, you can then start expanding your knowledge, like, oh, well, my piece talks to this other piece, and that piece talks to this other piece. And this is how you build up that knowledge we were talking about. It just takes time. One thing that may be catching your attention, though, is I keep using this word component. And you're like, is that like an Angular term? Is that a React term? What does component mean? Well, to put it very kind of generally, right, when we talk about a component, it's usually something that's written in the language, and it typically uses multiple libraries, all of which sit on top of some framework. I know it's a bunch of word salad. Let's go a little bit more in detail, right? So here's our example web app from before. Let's focus specifically on the front end. So Angular is a web application framework, right? I can do front end development with Angular. It's a framework. It handles routing and showing certain screens when needed, so on and so forth. But all the code to use that framework is written in TypeScript. So that's actually the language. And then to help Angular do certain things like run test cases, making API calls, and more, I'll use various libraries. And those libraries may be written in TypeScript, may be written in another language. It actually doesn't matter per se. But the big thing is it's all three of these things working together that'll make up a component here. So some good news or bad news. If you're at the role and you're at the company, you've already got experience with the languages and frameworks that are being used, great. All you need to focus on then is learn how they're used here. Every company does things slightly different. You need to learn what that nuance is. However, if you're at a company and they're using a tech stack that you're super unfamiliar with, you get to learn everything. Congratulations. My advice here is to start finding some really good resources. So books, videos, documentation, or posts to help get you started. The good news is that you work with a team, so someone will be able to help you out. But once you've got a little bit of information to get started, my advice is go build stuff, right? Just go build something with this new tech you're having to deal with, right? It doesn't have to be world changing. It doesn't have to solve like, 8 queens problem, whatever. It doesn't matter, right? Just build something to get started with it, right? So, hey, you're learning Angular and TypeScript. Cool. Try building a simple web app, right? Maybe it's a to-do list application. Maybe it's a Trello clone, depending on how aggressive you want to be. Hey, you're learning how to do web API stuff in C#. Cool. Try building out some simple APIs and then experiment with that, right? I'm a huge proponent of building stuff. And, I've been, coding for over a decade now. And when I pick up a new tech stack or a new approach, I build stuff with it. And it sucks, right? The first time, it's going to be really shoddy. I do a little bit of woodworking, and it kind of relates to me a little bit because the first time I built something, it wasn't square. It was a little bit out of kilter. It wasn't very smooth, but I learned a whole ton about the process. That's how it's going to be when you're learning new stuff, right? You're going to build something and it's going to technically work, but the code's going to be complete mess. It's not going to be easy to maintain, and that's okay. That's not the goal, right? The goal is to start building something, and here's why. Because you're going to level up over time, and what I found is that your leveling up looks like the following. You're going to be handed some task, and you're like, crap, I only know how to do like maybe half of this, if that. So then you're going to do some coding, and you're going to make syntax errors, compilation errors, logic errors. You're going to fight with the tooling, fight with your editor, just deal with a whole bunch of stuff. But while you're doing that, you're building up a crap ton of experience. And as you're building up that experience, oh, that error, yeah, I've seen that before. Here's how I go fix it, which gives you confidence that you know kind of what you're doing. And then as you start building up confidence, you'll take on a new task, and then you'll keep going through this process over and over again. And that's how you become an associate engineer. That's how you become a mid-level engineer and a senior engineer, and so on and so forth, is really going through this loop multiple times. Other thing to call out, you're working with a great team of engineers. They want you to succeed, right? You just joined this company. They don't want to bring you in and be like, oh man, I don't want to work with this person, right? They want you to succeed. They want you to be awesome, because if you're awesome, you actually make their lives easier. So they are deeply invested in watching you be successful, right? I'll kind of glaze over this a little bit, but one thing to keep in mind too is when you're learning stuff, just be selective. So for example, learning how to calculate rates is something that's kind of important. Learning how our authentication framework works, that's cool, but that doesn't change a whole lot. So you can always learn that a little bit later. All right, so I'm just doing a quick time check. All right, looks like we've got about 20 minutes or so. So let's talk about how do we go from idea to reality? What processes do we follow, right? So if you're not familiar with it, there's something known as the software development lifecycle. And it's really how does someone go from an idea to being in the hands of people? Every company has some flavor of it. It's just that there may be more steps to each part of the process. So at a high level, you've got requirements gathering. So what do we need to build? 2, planning is, okay, if we are going to build it, how long is it going to take? 3 is, hey, we're going to build the thing. How are we going to implement it? 4 is, hey, let's go build the stuff, right? Let's do hands-on keyboard. 5 is, hey, let's make sure this thing actually works the way we expect, right? So you built it, let's make sure it's working. And then 6 is the fun part where you actually give it to the customer and you're like, hey, go try this out. And then they tell you, hey, yeah, it doesn't handle this use case. That's totally key critical to me using it. And then you go back to step 1 and then you rinse and repeat, right? My recommendation at the very beginning, especially if you're new to the role of engineering, is to focus really on the build step, the testing step, and the maintenance step. You'll learn more about the other 3 over time, but you really need to focus on these 3 instead. So I've already mentioned a little bit, but development's focused on really writing the code, right? So hands on keyboard, getting stuff knocked out. And it's not just technical knowledge, it's process knowledge. So sometimes the technical knowledge is, how do I get the code on my machine? How do I build and run it locally? How do I share my changes with others, right? How do I deploy this stuff? Process knowledge can be things like, okay, how do I know what to work on? How do I know if something is done? What does done mean here? Because depending on the company you're at, done can mean all sorts of things. So an example of that in play here is, yeah, our code is stored in GitHub. So when starting work, we get the latest changes from there, and we create a feature branch, commit changes to it locally. And when the work is done, we create a pull request to merge those changes back into main. If you're not used to GitHub, some of those words may make you feel a little bit like this, where your eyes just kind of glazed over and you're like, oh goodness, that's a whole bunch of stuff. Let me be the first to tell you, it's okay. That's fine. That's normal. Let the person that you're working with know that, and they'll gladly go into detail. This is also why you're taking notes of stuff, right? Testing, right? So testing is make sure that stuff's working the way we intend, and it has some technical knowledge with it. Are there automated tests? And if so, how do I run those? Is there a naming convention? Are there certain standards? Where the heck do I store this stuff at? Tons of process questions here too, like who actually is responsible for testing? Is that an engineer? Is that another person? Okay, cool. One of her tests failed. What happens next? Do I need to go create a bug? Do I need to go let someone know? If I have a request for testing, so let's say I need to work with another team, who do I speak to? And how do I do that? Is it email, chat, smoke signals, carrier pigeons? Like what's the process here? So depending on the place you're at, this is one I found to be pretty realistic, is engineers are expected to write all these types of tests. However, we do have a separate team that handles both performance testing and security testing. And the big thing we need to know is before we release this new feature to our customers, we need to schedule time with that team so that they can run their performance testing and security testing. Once again, if you're new to testing, half these words may have made zero sense to you, like, Cameron, what's a unit versus integration versus end-to-end? That's okay. You'll learn, right? You're going to learn because you're going to be doing. And so relax, just write down your notes of things you might run into to follow up on, right? Last but not least, we're going to talk about releasing, right? Congratulations, you've written the code, you've tested the code, things are awesome, we're going to deploy it. We're going to give it to our customers, and that's awesome. Unfortunately, there's tons of technical knowledge, right? What environments are there, right? Usually you don't go straight from your local machine to production. Usually there's some stuff in between, but what are those? Let's say you have to change how things get deployed. How do I do that? What tools do we use to even do all this stuff? I've got no clue, right? So these are all bunch of questions you may have. And then there's tons of process questions, right? Like, who actually deploys it to the environment? Is it me? Is it automated? Is it someone else? Who makes the decision to deploy it? So cool, I know I can hit the button to deploy it, but who tells me I can go do it? Can I do that anytime? Or do I avoid Fridays at 4 p.m. because I actually want to enjoy the weekend? Right? So a bunch of stuff here to get to know about. So an example that you might run into is something like the following, where we've got 3 environments, test, beta, and prod. Code automatically gets deployed to the test environment once a pull request has been merged in. Test environment's really only used for our automated test. And if everything looks cool, we will have the engineer push their changes to the beta environment where we've got more realistic workloads, right? So some people are actually trying to use the app. And then assuming that looks good, both product and engineering decide when to push those changes to production. To kind of help keep things consistent, we use a tool called Circle CI that allows us to script out our builds and deployments. Once again, this may have been a whole bunch of what in the heck, and that's okay because you're going to learn more about it over time. All right, so just keep calm, take a deep breath. So you're going to learn this by working with others, and the way you're going to do that is you're going to most likely get assigned a mentor or a pair. And that mentor's goal is to help you get your first work item completed. When you take on your first story, your first piece of work, you're going to take it on from the coding, the testing, and the deployment. And while you're doing that, you're going to be asking them tons of questions, and that's okay. That's part of it, right? You've got this natural release valve. And yeah, it seems like a lot, and that's okay. You will get there just by asking those questions and kind of figuring it out. Peeling back the curtains a little bit. one of the metrics I will measure a company with and how successful I am as onboarding is if I bring one of you all in to join my team, how long does it take for you to get something that you've written into production? My internal goal is to have you've written something to get in production within your first 2 weeks. And that sounds crazy. That sounds really aggressive. Not at all. Totally normal, can totally be done. But once you do it for the first time, you're going to get a lot more comfortable with how this stuff works, right? And so you're like, all right, Cameron, cool. I can now write code. I know how to deploy it, test it, and I do all that stuff. But how do I know what to work on? Well, to help you out, most companies have some type of methodology where they know how to bring in the work, break it down, communicate out to who's working on what, when's it going to get deployed, so on and so forth. There's a ton of methodologies out there, but here are some of the most common ones you're going to run into, right? If you've heard of Agile, then you are most likely familiar with Scrum, Kanban, and SAFe. Those are some very common methodologies under the Agile framework. You also have other methodologies like Waterfall, spiral-driven development, and then rapid application development. These are just methodologies, but the cool thing is if you know what the company uses, then you know 80% of how they're doing stuff. So if you know a company is a Scrum methodology, then you know that they're going to have certain meetings held at certain time intervals with certain people. You automatically know that. As you work at more places and get exposed to more methodologies, I have found that your ramp up time on this stuff can drop down to just an afternoon, if that. At that point, it's just getting the meetings on your calendar. But let's take a look at Scrum, right? So if you're working in a Scrum shop, they say that, yep, our goal is to deliver software to our customers every 2 weeks. We call those things sprints. At the beginning of said sprint, we'll sit down, talk about what we can actually get done over the 2 weeks. We call that planning. And during that sprint, every day, we're going to have something called a stand-up where we talk about, hey, here's the cool stuff I did yesterday. Here's what I'm working on today. And here's what any blockers I've got. Goal of that meeting is that if you've got a blocker, someone can help you out and get you unstuck. At the end of the sprint, those 2 weeks, we have a retrospective to discuss, hey, this worked out really well. This isn't working so great. What can we do to improve? Congratulations. This framework is good enough to get you started at most shops that do Agile, or sorry, that do Scrum of some sort. There's tons of resources and other stuff out there to learn more, but honestly, you'll learn it as kind of when you start the role. But the big thing is just knowing what the methodology is so you can kind of game plan that a little bit. And like anything else, right? As time progresses, you'll get used to the process. You'll start developing a rhythm, right? You're going to be used to going to certain meetings, talking to certain people, doing that. Once you develop that rhythm, you'll start able to contribute instead of just following along. Last but not least, let's talk about the people, right? Who do I work with to succeed? A common mistake engineers make is that they feel like their days are going to be like this, where you're working in isolation, working by yourself. Don't get me wrong, you're going to do that quite a bit. You are an engineer, after all, code doesn't need to be written. But in reality, you're going to be working within a team of people. So it's not just going to be you. And the reason why is a really good expression to kind of summarize this, at least in my mind, is if you want to go quickly, go by yourself. But if you want to go far, you go together, right? And that's because you can kind of help each other out. So let's talk about what your team is really going to look like. The first person you're going to run into is your team lead, right? So some companies will call this your team lead. Some will call them your engineering manager, but most likely this is the person you report to, right? This is the person that's going to talk to you if you're doing great, not doing great, performance, all that fun such. They're also going to be the one to help you set your priorities. So they're going to tell you like, hey, Cameron, I'm going to need you to work on these things, right? The other cool thing about your team lead is they can help direct your questions to the right people. So if you have questions about a certain process or a certain thing, they'll be like, oh yeah, go talk to Jan about that, or go talk to Carly about that. Right? They can help you kind of route those questions. The other thing to keep in mind is if you've got team, you can either have a really good team lead or a not so great team lead. And if you have a not great team lead, it can be really frustrating at times because it feels like you're not able to communicate with them. It may also just be really frustrating because you're doing everything you can to be successful, but it's not like they're helping. When you run into those situations, the best piece of advice I can give is try to find someone else on the team to work with to kind of help you out some. When your fun fact of the day is when people do decide to change companies, most often it's because of their manager or their leader, right? Very rarely is it people quit a company outright. It's people they're having to interact with, and the team lead really does set that tone. However, you get a team lead that you can kind of click with, start getting along, asking really good questions. This could be one of the best things that have ever happened to your career. I attribute a lot of my success in the career to one of the first team leads I ever had, a gentleman named Jeff. And he taught me a lot of core fundamental things of how to be an engineer. And I've used those principles and practices throughout my whole career and have been super successful because of such. So how do you build up these relationships with your team lead, right? Like, how do you do that? Ideally, you met them during the interview, right? So you had that conversation with them at some point, but now that you've got the job, you're going to want to make sure you schedule an introductory conversation with them, right? And during that introductory conversation, you're going to want to ask them about what their expectations and get to know them a bit, right? It's not just always work, because you care about them as somebody you work with, but you need to care about them at least a little bit about as a person, because guess what? You work with people, they are human, they're going to make mistakes, they're going to mess up, they have families, they have interests, they have hobbies. You're going to want to know at least a little bit about some of that. So, excuse me, to kind of continue on these expectations, you get this intro combo. Make sure you also get a one-on-one scheduled. So this is either a weekly or a bi-weekly meeting, usually 30 minutes, where your job is to talk about whatever's on your mind. Maybe it's questions, maybe it's feedback you've got, whatever, but you really want to have that conversation with them. A mistake I see a lot of engineers make is they go into these one-on-ones and they spend the entire 30 minutes talking about whatever comes to their mind, which the first couple of ones should be like that because you're getting started. But you also need to make, messed up something on there. My apologies. But when you're chatting with them about these things, make sure you ask them how you're doing, things you should be focused on, etc. The mistake I see engineers make is that they focus all on this and never ask their team lead, like, how are they doing? Right? Like, what's going on in your world, right? To understand some things. So, there we go. So sorry, I had something confused there. But yeah, get to know your leader. What are they like outside of work? Any hobbies or interests? I would be very shocked if you had a conversation with your team lead and you had literally 0 things in common, because you have at least one thing in common. You both work at this company, right? You have at least something you can chat about, right? I've found out through discovery that I've had leads where we had similar interests in music or books or TV shows, programming languages. Heck, I realized that my team lead also had a degree in mathematics. So that was super cool. Like, oh, it's another math nerd. Awesome. Right. The advice to kind of give here is, in an ideal world, you'd be really cool friends with them, but you don't necessarily have to be their best friend. You just have to be friendly, right? You got to be able to have that working relationship with them. Let's talk about your team, right? So you're going to be spending the majority of your time with your team. So because you're going to be spending a crud ton of time with them, you've got to know them and you got to understand how to work with them, right? And as you're meeting your team, you're going to really be assigned a mentor. I mentioned this earlier. So who's that person? Who's helping you onboard? Whoever's helping you out, you got to schedule that combo with them. You want to introduce yourself. You want to take the initiative on that. Once you know who they are, you're going to want to have daily sync ups or pair with them a lot, right? You want to be spending a ton of time with this individual to really get up to speed on things, right? As you start doing this, you're going to expand your network. You're going to start meeting the other members of your team. You're going to start scheduling more intro conversations with them and get to know them a little bit better. And you'll be doing this over time. And my preferred way of doing this is just like over coffee, right? Over coffee, over tea, right? It doesn't have to be a big formal thing. And when I do intro conversations, they look like this. I introduce myself, tell them a little bit about me, have them introduce themselves. And then based on how they introduce themselves, we'll talk about stuff, right? Maybe they mention like, oh yeah, hi, my name is Jenny and I'm an associate engineer. I've been at the company for 3 months. Cool, talk to them about like how their first 3 months have been, right? Talk about some stuff that maybe they wish they had known when they started. But some general questions I ask, right, is what's one thing that you're really good at, right? Maybe that person's really good at code reviews, or they're really good at dad jokes, or they're really good at recommending the best coffee to get from the kitchen, right? What have you. Some other fun questions like asking are, what's one thing you appreciate in a teammate? Because if that's something that you naturally do, awesome. This may be an ally or a friend of yours in the making. What's a characteristic that you don't like in a teammate? You should probably not do that or exhibit that characteristic while you're around them, right? Because that's probably going to get on their nerves a little bit. Once again, right, in an ideal world, you would be best friends with everyone you work with. Sometimes that happens, and if so, cool, more power to you. But you still need to be professional, right? You still need to have that working relationship. Let's go back to our team. Who's all on our teams, right? We've got most likely engineers on your team of various skill levels, right? So associate up to senior. And in addition, you might have some other people on your team: Scrum Masters, business analysts, product owners, testers, support engineers, DevOps, a whole bunch of people. You just need to know who they are, and you'll know that through those conversations. So I am going to take a pause here because I think we had getting close to around 1 o'clock. Is that true, Law, right?
Yes, sir.
Hard stop at 1, correct?
Yes, sir.
Oh, no, that's excellent. That's all I need to know. Okay. So unfortunately, have ran out a little bit more time than I was expecting, and that's okay. The two things I just want to call out is your team will either be a really small team or a very large team. Depending on the size of the team may dictate how much more notes you need to take on stuff, and that's okay. Just continue putting in that effort. The last thing I want to call out is something to help you keep track of this stuff, because there's a lot of moving parts. So in the link I put in the Zoom chat, and I'll make sure it gets zoomed out, is I've created a Trello board to help you keep track of all the tasks that you need to be doing when you start a new role. Feel free to follow the instructions on the first card, and it'll tell you how to clone it and get stood up, but then you can start working through these pieces and get things situated. So sorry for a little bit of the rushed ending, but I did want to make sure I respected your all's time. So thank you all so much for letting me hang out with you for the hour. Hopefully I was able to help give you some advice, maybe remove some concerns. Hopefully it didn't scare you too much with all the technical stuff of what it may be like starting your first role or starting a new role.
Cameron, this was super awesome. I just want to thank you so much for providing all of your knowledge and expertise today. I know that I found it very helpful, and we'll definitely be sharing this with my team. So thank you again.
Yeah, thanks for the kind words, Tammy. I appreciate that.
Thank you very much, Cameron. We really appreciate it. And thank you, Tammy, for connecting us with Cameron.
And thank you to all the participants. We are greatly appreciative that you could stop by and hang out with us and Cameron and Tammy today. So come
Absolutely.
back soon.
Yeah, thank you, everybody. And if you have any questions or are interested in hearing about more library programs, I am going to put a link right here in the chat that hopefully works. That it's just a very, very quick survey that hopefully will encourage you all to tell us what kind of programs you'd like to see with our wonderful partners like Queen City Bytes. I also encourage you all to, if you live in Mecklenburg County, you can get a free library card that will connect you with a lot of free resources that may help you if you're a budding engineer. We have a lot of things besides just books. We have a couple of great tools that include all kinds of training for coders, for software that you can access for free with a library card. One of those is called LinkedIn Learning. Typically, a lot of people pay for that for access to that. If you have a library card, it is free. I will put something else in the chat that shows you just how to get access to it. But that is, I just wanted to spread the word that that is something you can access for all kinds of training resources that's free with the library card. And another one that it's a little bit newer that some folks aren't aware of is something called O'Reilly. That's also a resource that I just put in the chat that has books and training materials. And Cameron also mentioned, sorry for all the links here, and thank you again for staying on. He mentioned the book, Getting Things Done by David Allen. Yes, good news. We do have it in the library catalog, and it looks like it's a very popular book. Well, the reason I say that is because we have 4 copies of it. All copies are checked out. There's one on hold. It is available as a book on disc if you have a way of playing CDs. And it's also available as an ebook as well. But all copies of that are checked out as well. And there are 8 people waiting for it. So thank you, Cameron, for for that recommendation. It's very popular. But yeah, and Law, if I forgot anything, but that just gives you guys an overview of what you can do with the library card. And again, just encourage you to check out those links, fill out the survey if you have a chance to. And thank you again, Tammy and Cameron, for joining us.
Thank you, everybody. Definitely appreciate it. Until next time.
Till next time.
Thank you. Bye-bye.
Bye, everyone. Have a good afternoon.